We're going to look at some mathematical methods to solve problems, and we're going to use the cosine rule, and we're going to look in 3 dimensions, but not all at once. We're going to look in a profile and then a plan view. We're going to include bearings as well as angle of elevation and a few other things. A surveyor records that the top of a nearby church steeple has an angle of elevation of 5 degrees and the clock of a top of a clock tower has an 8-degree angle of elevation. From his position in the middle of the paddock, the church steeple is located at north 10 degrees west, while the clock tower is at north 15 degrees east. If the tops of the church steeple and the clock tower are both 30 meters above the surveyor's level, what is the distance between them? So on these right-angled triangles here, we've got the surveyor, so I'm going to represent the surveyor with a dot, which might seem a little bit unfair, but surveyor, you are just a dot. Now she needs to be represented twice. We've got 2 diagrams. The first sentence is relating to this blue triangle here, okay, and it's a 5-degree angle of elevation which is above the horizontal. The last sentence says that that level is 30 meters below where the steeple, church steeple is, which I'm going to call an S, so therefore that's 30 meters, that height there. Likewise, on the other diagram, if we look at the second and also the last sentences, we've got an 8 degrees. Notice how I've drawn the diagrams in 2 separate triangles. It makes it easier. 8 degrees. It's the same surveyor, but this is it's rotated into the page and swung around that way. So I'm not interested in that swinging around bit yet. That's when the bearings will kick in. We also have 30 meters. And we've got a tower, okay, a clock tower, which I'll call T for tower. Now I'm interested in the horizontal distance. We've got the distance along horizontally from the surveyor in a horizontal manner till we get in line with the church steeple. I'm going to call that X. And I'm going to call D the distance from the surveyor horizontally till we get in line with the point T, which was the tower of the clock. Because these are right-angled triangles, I can use sine, cos and tan. So if we rearrange the expression for tan, x equals 30 over tan of 5. You can pause the video and check that out yourself. And thus, that will be 342.9 meters to 1 decimal place. Likewise, for the other diagram, we can use tan there as well. That will be 30 over tan of 8 degrees, and that all crunches to 213.5 meters. So they're horizontal distances, okay? They're not at a slope. They're not taking into account height. These are horizontal distances, okay? It's the range in a sense. Now those two amounts are going, or those two distances, quantities, are going to be used when we're looking at the final part where we've got to take into account the direction, the bearing. Now that one there above was a profile view, just looking at it from side on in a sense. And this one here is going to be a plan view, looking at it from a bird's eye view, all right, from above. Okay, so you can see we've got the surveyor again at point O, and we go out to S, but we can't tell S's height, and we're not interested in height here in this diagram. We want to know how far apart they are, and that's a horizontal distance too. So we want to find side ST. Okay, we want to find the length of side ST on that triangle. Okay, so you can see that we've got the 342.9. Okay, it's been translated. Remember, that's along the horizontal. Okay, it's not up the slope. And this one, you can see that's been translated onto this diagram here. And again, that's not up the slope, that's perfectly horizontally. Okay, now because these two are at the same heights, we can look at the horizontal distance at the surveyor's level beneath them, and that will still be the distance between them, because the distance between S and T at the surveyor's level, i.e. we stay at the same level, is the same as the distance between S and T at 30 meters, and they are both at 30 meters, you might remember, so we can use that. Okay, see, they're both at 30 meters above the surveyor, so it's just a translation of that dimension upwards. We're going to use the cosine rule because we want to find a third side. It's a non-right angled triangle. Alright, and we're given two sides, and included angle are given. Okay, so we're going to find the side ST, the length of it. I'm just going to call that ST. So using the cosine rule, okay, and this diagram here, ST squared equals OS squared plus OT squared plus 2 OS times OT times cos of the angle SOT. Oops, that's okay. I just fixed that. Looked like an equal sign there. I've just made that clearly subtraction. Sub the values in now. Okay, and the values are subbed in. Notice how the angle is 25 degrees, you see. Okay, and hopefully you can work with bearings and directions from our previous videos to set that diagram up, by the way. Crunching all that. Okay, so we get 30,462.6. Take the square root to get ST, and you'll find that those points are 174.5 meters apart.